So I'm going to walk you guys through my solutions to problems 18.1, 18.2, and 19.1. So in 18.1, we are asked to carry out the integration of the first term on the left-hand side of equation 18.3 to obtain the first term on the right-hand side of that same equation. So we have 18.3 written out here. So we basically need to carry out the integration on this term in order to produce this term. In the book, does basically the entire operation for the y term on both sides. So we can essentially just repeat that process for the x term. So we start out with the double integral of ux. Then we're going to split up the integral. This is based on figure 18.1. We split it up based on the enclosed surface that we're looking at in this particular case. We can then integrate this inside integrand. Then we will end up with this expression inside our outside integral. We then integrate that, or turn it into a contour integral rather. We can then utilize figure 18.2 to find another expression for that unit vector nx, which in this case is equal to cosine alpha. And then we're able to write our final answer, that is the same term we see here. Moving on to 18.2, we're asked to express the surface integral over a closed surface to S as a volume integral over V, given two different integrands. So in part A, we're given this guy. So I just converted that to index notation very quickly. We can then put it inside our surface integral, and we recognize it's in the form, or same form rather, as equation 18.2. So we can sub in this portion of that equivalence into our original integral here, and then we simply take the derivative inside the integral of this expression, and we just use the chain rule here, and we end up with our expression for the volume over that enclosed surface. Part B is a very similar process. In this case, we have a what looks like a cross product in index notation. So it may seem a little tricky, but it's not that much different from part A. So this epsilon is, if you remember, either 1, -1, or 0. So that's just a constant, so we can move that outside the integral. So we do that in this step. Then we can utilize equation 18.2 again and fill that in. Then again, we take the derivative here of that term inside the integral, and then we use the chain rule again, and that's our final answer for the volume. Problem 19.1 tells us to fill in the details of how to obtain equation 19.15 from equation 19.14. So I've written those out here. We just need to fill in the intermediate steps. So first step is just to go ahead and take the derivative of what's inside the integral in 19.14. So we do that, and it's all just a sort of long chain rule. So we get this expression here. We then recognize that we can use equation 19.4 here, which gives us another expression for the first derivative of j with respect to time. So we can fill that in the next step, which you see here. You can then see that we have a j term in each of those individual expressions inside the integral, so we can factor a j out, and then do a little bit of rearranging to then utilize equation 19 point, it's a terrible star, 19.9, equation 19.9. We then recognize that from the textbook it's just a zero, so we can eliminate that entire term, which simplifies things for us quite a bit. And then we condense everything back together, and we get the simplified version of 19.15.